So, starting the stream, and let's go for it. So, since last time, I looked at the implementation and figured out that this multiple interpreter supported is the default, so we don't need this.
Okay.
This is the default, but it's not documented properly, and I have an issue for that, and I'll fix the documentation eventually, but we shouldn't need to use that. So the problem is somewhere else, and I honestly have no idea where it is. Any news on your side? Have you figured out how to run the build and tests?
I have. So there is a chain of commands, and apparently the instructions to to compile RPM are buried deep inside the installation documentation. So it was, it's no wonder we couldn't find it, but the test documentation as it is works. So to run the Python test suite, I have provided a command in the chat. It should be make check. But before we can run that, if you try it now, you will probably hit no rule to make target check. Oh, I guess without me.
Yep.
Yes, because it's a CMake project, and Panu, whom I trust, told me that the basically the sequence to build the RPM module goes like that. So you should create _ build directory, then enter it, then run CMake to the parenting directory, and then make it. And to make, and it may be beneficial to run make with the -J option to make things quicker.
Sounds good. So I don't have CMake installed, which I guess is easily fixed. I do have an alias. A personal shortcut which will run make with -J, so I'm fine there.
Oh, and now you start hitting things.
Of course.
And I figured out that in the tests directory, there is a Docker file which specifies what to install to Fedora in order to be able to build RPM. So that Docker file contains a lot of packages.
So what happens if I just build DNF build up RPM?
Ah, that's an interesting
endeavor. 24 packages.
That looks like it could be.
Yeah, that's working.
Okay.
Yeah, that's the build instructions we have for CPython. Just DNF build up CPython. Hopefully the Fedora packages have the dependencies right. Okay.
And now you should be able
to
run the make check test ops
Python, but I need to do that
in that
build. Let's see. Right.
Oh.
Make check. Nope.
Wait a moment. Let's see. What is in that directory you just created? This
Built.
underscore build.
Everything's built.
It looks well. How come it works? For me. Maybe there is an option that you should configure. If you take a look at the oh, I know. Maybe I know. There is in the tests directory there is a README that says
De-enable test suite on.
yeah, something like that.
Okay, let's try that.
I start having a feeling that it may not be there.
Oh, yeah,
Yes.
that was it. All right.
Oh.
Everything failed. Everything failed. Which means now I can. Wait, first of all, if I do make check it in Stew, it builds stuff, makes a container, builds stuff in there, installs it in the container, hopefully, and then runs the tests. That's perfect. Okay.
I'm not sure. Just one more option to the CMake, whether Python is actually compiled.
Oh.
Because that looks weird. That all of the
well, there are some test results. RPM tests log. Where would
I was doing the same changes we were doing last time, and I've got tests passing, and there should be when you the RPM tests log is in tests directory. If you get it,
right. Oh,
build
and
tests
dash
RPM
build.
log.
Right. Where am I? RPM build tests.
And this is it.
RPM tests log. Blah 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 blah. Detailed failed tests.
Failed. No such file or directory. User bin Python 3.14. Why user bin Python 3.14 though?
I guess CMake configured it with the latest Python I have installed on my machine.
Oh, that's cunning.
So we need to tell CMake to like which Python to use. Enable Python. Find package Python 337. Components interpreter development required. Okay, no idea how to fix that.
I may have removed Python 3.14 from my system for a while, just to make it configure project correctly.
Result variables. I don't want result variables. executable. Okay, so Python executable. Python executable is user bin Python 3.13. Nope. Any unspecified variables were not used by the project. Well, CMake is nice to tell me that. I have 330, so it should use something. Huh. Okay, if you set the variable with a type.
Uh-huh.
Okay. It does something else. Let's see. RPM tests log. Nope, still 314. Clear any caches by removing the build directory, and does it
Found Python, I saw it. Found Python 3.14, a bit lower in the output. There is it, 1/3, yeah.
Don't find 314. It's oh well. Well, another thing we could do is change the container, right?
To have Python 3.14?
Yeah. Well, okay, so didn't honor Python executable. Which is weird. Should have. We use Python library. No. So apparently I can specify a range.
Mm-hmm.
And it doesn't like 314, so maybe something like that.
Yes. Looks much better.
Okay.
So now the test should pass for you.
Yes! Yes!
Ah, you're there.
Nice, great.
So now we'll run
Okay,
this.
so I will commit this so that it doesn't appear in any further commits.
I also learned one more thing.
Mm-hmm.
I learned that RPM uses C99 standard,
Mm-hmm.
and I was told that we can use this dot notation when defining module.
Perfect. C99 is great. So the standard that's used for Python headers is unclear, and we have recently defined it to be C11, which is 12 years later than 99, but doesn't really have any. And it should still be compatible with C99. All right. So we go back to the RPM module, and my previous commit was switch the Python wrapper to multi-phase initialization, and it works.
Yeah.
It works with that, which is great. Guess I should push this so you can see it. So, right.
When I was going through the video to refresh my memory, and I made the same changes locally just to make sure I follow what's going on. So I've got the changes, but it's good that you push.
All right. So. Where were we?
So we were talking about writing a test for this. But we're working under assumption that we can somehow run this interpreter, which we can't.
Yeah, the writing a test for that will not be easy. Okay, I don't want build tests, I want tests, right?
Yes.
Python.add.
It's a beautiful format. I cannot start like understanding it.
Yeah, but I guess it uses some kind of testing framework on top of the M4.
Yes, RPM test defines a test, and it runs some predefined pieces of code defined in the local at file, which provide a frame for what's going on in the test. And one of those things that are defined there is RPM pi underscore run, which is always executed with each of those RPM tests. And it imports RPM sys OS, does some macro expansion, sets certain environment variables, deals with this ASAN thing we encountered last time. So basically with each of those tests, RPM is already imported for you. And then you write some code in one of those square brackets objects. And the second square bracket object contains what is expected to be printed out. And that's my print function.
Okay. So that means if I add a new test.
That's the name of the test. Yes.
Test, and I print hello. And then the result should be something else. So let's make it fail. Good way to test a test, right?
I'm not entirely sure why the latest test uses print instead of my print. But
what's my print?
My print is also defined in that place, and
what place is it?
Local.add in the same directory as tests.
Local.add. Oh, nice.
Yes.
That's my print. Sys std out, right?
It looks like it prints.
Yeah, this is right. So in Python 2, the print statement was a bit weird regarding its handling of new lines and separating arguments. So I guess it made sense to do something like this, which of course has its own problems. So yeah, it only has one argument. If that argument is a tuple, this will just fail. Yeah. Well, if you call print with one argument, this is exactly what it'll do in Python 3. So it's not necessary anymore to use my print. Maybe we should change it, or at least add a comment that we don't need to use my print anymore. I wonder if that was raised when this arch score was added. Let's see. Where is
RPM software management?
There we go. Thanks.
My favorite name of the organization.
So this is tests RPM Python. Let's see who added those. Add a simple arch score tests. In December.
It almost looks like he did just by mistake, and it worked, so why bother?
Yeah, looks like a mistake. Okay, no discussion there. We can start our own discussion if anybody asks why we use print and not my print. I guess there's no comment anywhere else about my print, right?
Nope, it's only defined and then used in all of the tests, except for one.
Right. Maybe let's add a comment there.
Mm-hmm. Mm-hmm.
But that's not the important thing. So we want to test how RPM works in subinterpreters. The problem with subinterpreters is that there is no Python API for them, and you need to use C APIs to start an interpreter, which looks like it would be quite cumbersome from these tests. We might add a test function to RPM, the RPM module itself, but then we can't really test the current situation. I guess this test has RPM already imported.
Yeah.
Which is also not really good. Well, the other thing we can do is use Python's private API for subinterpreters, which should be okay for prototyping the feature. And we know we're, at least I am, testing on the 3.13. So let's see if we have underscore interpreters, and there we have create. Okay, and then we have run string, which takes an ID of the interpreter and a script.
Mm-hmm.
I think we did that last time, right? I just don't remember.
Yes.
Okay, and then we should probably close it. What does the crypt do? Destroy? Destroy. Yeah, I'll just try the current one. Okay, so let's do that. Okay, import interpreters. Let's make one. run parse string inside that interpreter. And now literal Python code, so I do it like this, just to get a block. Right, there's an if one or if true, just so I can import the next line. And so what happens if we get an error? We get a result back. Okay. What happens if we get nothing? Oh, we get none. Okay. We get none, so we should print the result and get back none. Let's see what happens then.
Isn't there a bit too many quotation marks?
Oh.
Just one too many.
Now we have a different failure, and this is test number 136. So if I look at 136 log, I should get that log itself. What does this say? This is the test. Oh, this is the whole test.
Yes.
Nice. Import RPM sys dp path RPM add macro myprint ts, and this is our test itself. And we get import error. Module RPM does not support loading in sub-interpreters. Where do we get that from?
Yeah, that's what we were looking for last time, because that's not the thing added recently.
Right, we wanted to say cannot load RPM module more than once per process. So if I added this,
it behaves the same way. No, not the same way.
no, I get that it's not defined because it's not part of the stable ABI, of course.
Oh. Yeah, that's good.
So this thing is the number 1. And PyMod multiple interpreters.
Who's number 3? Right.
Right. It's number 3. Okay. So never write this in production code, obviously. And the tests now say the same thing. I know. what the problem is.
Mhm.
So there are two kinds of subinterpreters. The first one, well, no, there are options you can set when you create subinterpreters. Because we gradually found out that the isolation is not as good as it could have been. So when you create an interpreter, let's see, PyNew interpreter. There is now a PyInterpreter from config, where you put in an interpreter configuration, where you can say if you want to use the main object allocator, which is something that you have to keep separate if you use separate guilds for the interpreters. You say if you allow forking, because forking doesn't really work with subinterpreters. Same for execs. You can disallow threads, daemon threads, and so on. So basically, you can just say that you don't want all the things that are causing trouble in like threading in general and interpreters in particular. And so this is restricting stuff, and the thing that it allows you to do is set own GIL. So the subinterpreter will have its own GIL, and it can run independently. And to do that, you need to use the use main obmalloc. And of course, the person who added this also wrote the internal API, and I assume the internal API uses the strict defaults. So let's see if create so config must be a valid interpreter config or the name of a predefined config, isolated or legacy. Okay, let's do legacy. It's a cute name for I don't want anybody to use this anymore.
I thought it's a metaphor for it's going to work for the next 50 years without issues.
And now we get our own message. Yes! Yes! Cannot load RPM module more than once per process. Great. So what changed? We added this test. We shouldn't need to specify the default, so I'll remove this hack and try it again. And that doesn't work. Oh, yeah, that just fails with our own message. Okay. And great. So now we need to remove this restriction, right?
Yes.
Of course, one way to do it is just to delete it. And voila, test is green. The problem here is that this line, PyRPM error equals PyNew exception blah blah blah, will set the global variable or the static variable PyRPM error which is defined in RPM module.c.
Here.
Oh, line 32. Here, right? It's at the global level, so this is static by default, which means if you load RPM in one subinterpreter, it'll where were we? It'll do that, and when you load it in another interpreter, it'll overwrite the old by RPM error. All right, let's try to demonstrate that in the test. So I should be able to say rpm.rpm. So what's the ID of what's this error? And print the ID here inside the interpreter, and then print it again. Let me just quickly check if this is the right thing to do. Yeah, and maybe we need this import here as well. I don't know if it's actually imported. It probably is. See? So yeah, so the first one is from the main interpreter, rpm.rpm.error. The second one will be from the subinterpreter, and the last one will be from the main one again. Right? And we can see that the first one is something, and then there are two other ones. So importing underscore RPM in another interpreter changed the error object for the main interpreter, which is of course really bad, because now if you do try except and try to cache this error, it will never cache the error because it's a different object now.
I see.
So what we do then is this init and add type, which creates a type and adds it to the object, and it also sets a global variable like before, right? So the rest of RPM doesn't really look what's in the module object, but looks at the global variable, which is here like HDR type, which is a variable defined in header py.h, like this one. Though this is external, and header py.c there'll be the actual definition somewhere, or maybe somewhere else. Anyway, it's also a static one. So the rest of RPM will look at this one, which is basically the last one that was set. If underscore RPM is imported again, it'll be overwritten. And that's there for all the objects, right? So two things we need to do. We need to add these types to the module object itself. Like the correct namespace to use for these is the module object. You can see the reasons in the how-to or the pep. You could also put it in various other places, but this is the one I prefer. And the more difficult part is changing the rest of all of RPM to use the thing that's in the module object and not the global variable. Does that make sense?
Yeah, on the surface level, yeah.
Okay. So let me commit this. Demonstrate the issue. And I know I've done this before on some branch on my GitHub. So rather than figuring it out again, let me go there. So instead of RPM software management, let's put my username, and there will be a branch called Python stable ABI proof of concept. No, that's the old one. Multi-phase init.
That's the one we are using now.
That's the one I'm using now. Okay.
ABI 3, I think it is.
ABI 3. Remove global state. Yeah, that's the good one. Okay, so it starts with turn-up debugging, which is, yeah, I just I added all the Pythons to the container. So I guess this is another way to add 314. And I run Python with xdef and xfault handler, which is nice for debugging issues. We don't need that. There's a check that ds count emits deprecation warning. This test failed when Python is set to show all warnings. So do you want to send a different pull request to RPM?
I can, of course.
Yeah, just take this commit then. And the next commit is like the meat of what we do, which is removing statically stored types. So what this does is it takes all the types and removes them. Right?
All the PyType objects.
Right. So there's always a header, .h, which has extern blah blah blah, extern PyType object HDR type. Extern means that this variable could be defined in some other C file. So whatever includes this header file will know that there is a variable HDR type somewhere, and the linker will figure out where it is. Then there's the C file, which does the same thing without extern, and this says the variable is defined here. Like this is the source file where we reserve the 8 bytes for the pointer. Right? Yeah, and this just happens everywhere, and this is really tedious to write. And because it's really tedious to write, apparently I used a tool. Commit generated with this semantic patch, C blah blah blah. And this is a diff. It says blah something something, and minus extern Python object t, where t is some magic identifier. And this is applied using spatch something. Right? So this is some magic tooling for semantic patches, where you can say what needs to happen to your code base and it does some automatic changes. Apparently it's used in the kernel for when there's a like when a function, when an internal function needs one more argument, they run this to add the default value to all the calls to that function, which is pretty amazing. So let's see. So I don't know if something changed in RPM that would make this exact patch obsolete. So maybe it would be better to reapply this. So let's see, I can copy this into RPM, name it, oh, this all the way around there, and then run spatch. Now I'm in the build directory, so I need the patch from there and there, and patch command not found. Probably better to use user bin as patch, because who knows what the package name is. Of course, the package name for spatch is coccinelle.
Mm-hmm.
Something happened, and we got. Wait for it. Yeah, we got the patch.
Mm-hmm.
It removed some blank lines, which I don't think it did before. But yeah, it should be the same patch. Hopefully it works for all the rest of RPM. So, oh, it says white space adjusted by hand. Cool. Was going for good patches, right? So we want this line, we want this line, we want this line, we want this line. So on. There's a bunch of them. Let me just commit it as is. And if they need a clean patch, I can adjust it by hand. Okay, of course, now when I test things, this won't even build because I removed all these definitions. Right?
Mm-hmm.
So let's look at the next commit. Remove static pointer to RPM error. Okay, so this is one. Yeah, so this is another static variable.
Mm-hmm.
I can just cherry pick. So the automated one just removed all the types.
Mm-hmm.
Now rewrite usage of moved objects. So all of these types, and I hope this is all of them because apparently they're listed in the patch, so we might need to check this patch before applying it. We'll probably not get to that today, but you can try it. So all of these are now not global objects, but part of some module state struct.
Mm-hmm.
And this will be a bit hard to understand because the module state struct doesn't exist yet. We'll need to add something that'll contain all of these, right? And then we'll need to add something to get to that mod state struct in all the places that need it. Right? The reason I did this commit first is to get errors. Right? So if I compile this, in all these 100 places, the compiler will complain. There is no mod state. Right? The next step after that will be to remove the static pointer somewhere. Oh no, define and initialize the mod state struct. So let's look at that one. So this is the definition. A struct that has everything we moved out. And then there's an extern this struct mod state, like a pointer to this struct. Right? So in this step, we have one single global instance of this struct, and we initialize it here with malloc, set it to zeros, and then all of the code that adds things to it already has this mod state, and this mod state is now global, so it can just be used. Right? And that should compile, and then that should pass tests. So let's see. Let me just. Can I just cherry pick this? No, let me patch it. Parse error around identifier. Oh, didn't paste all of it. And there's a conflict. Oh dear. Okay, so we.
You know why? Because of PyRPM error. Because after the patch, there was also one manual commit that changed on
right.
PyRPM error.
Okay. So we're out of time, so I'll commit this and leave it here, and see if you can apply the patch, apply the manual commit, and then we'll see if it compiles, and then we'll continue with the rest next time.
Sure.
Yeah, this will need some explanation. Okay.
Okay, thank you.
See you next week then.